Okay, so the next part that we have here is some section related to the derivative of polynomials and trigonometric functions. So in order to, there is a theorem over here. The following theorem, we start with the following theorem, which tells us the derivative of a polynomial function. So this has been called Theorem 7 here, although the number is not that important. It says that let f of x be equal to a of n x raised to the power n plus a of n minus 1 x raised to the power n minus 1 plus all the way up to a of 1 x raised to the power 1 plus a of 0 x raised to the power 0, which is equal to 1, so that's only a of 0. That's a polynomial. Be a polynomial function. Let this function be a polynomial function. Be a polynomial function. Where a of i's, meaning this is the plural of a of I, meaning that this is no variable or anything, just the plural of a of I, meaning that this is a of I, this is a of I, this is a of I, and this is a of I, meaning that the index of a changes, as you can see over here, a of n minus 1, a of n, a of 1, and so on and so forth. Where a of i's are all real numbers, and a of n is not equal to 0. Then the derivative function is given by d by dx of f of x, d by dx of f of x is equal to n times a of n times a of n x raised to the power n minus 1 plus n minus 1 times a of n minus 1 times a of n minus 1 x raised to the power n minus 2 x raised to the power n minus 2 plus all the way up to, basically 2 times a of 2 So before this I have basically before this term I would have a of 2 x raised to the power 2, so I would get 2 times, so that the derivative of this would be 2 times a of 2 x raised to the power 1, which is basically, which I can write over here, 2 times a of 2 x times x, plus basically then I have a of 1 x raised to the power so if I have a of 1 x raised to the power 1 is the same thing as 1 times a of 1 x raised to the power 1 minus 1, so this becomes x raised to the power 0, which is equal to 1, and that basically you will get a of 1 over here. So the derivative of this term becomes a of 1. and then a of 0 is just a constant, and the derivative of a constant is of course 0. So that if you have a of 0, this is just a constant, the derivative of that becomes 0. So then this becomes the derivative of your polynomial function, and that makes sense because we already basically using the algebra of derivatives, we said that if we had we said that basically the derivative of d by dx of basically f of x, for example, I don't know why I write fg, f of x plus g of x, for example, the derivative of this of the sum of these two functions was the sum of the derivatives of the two functions, meaning that d by dx of f of x plus d by dx of g of x. So you can think of these terms as functions, and so then basically take them, and also we showed that basically d by dx of x raised to the power n is equal to n times x raised to the power n minus 1. So then the derivative of this function becomes the sum of the derivatives of all of these terms added together. And for example, the derivative of this term would be, for example, a of n, x raised to the power n, would be basically a of n, you can keep it as it is just a constant, and n comes over here times n times a raised to the power n minus 1, n times a raised to the power n minus 1. So that becomes, for example, the first term over here. The second term, for example, you would get a of n minus 1, x raised to the power n minus 1, so this would be, this exponent comes over here, so this becomes the derivative becomes n minus 1 times a of n minus 1 times x raised to the power n minus 1 minus 1, which is the same thing as n minus 1 times a of n minus 1 times x raised to the power n minus 2, which is basically this thing over here. So, and so on and so forth. So that's basically how you can, that was basically the proof of what we have written over here. So now if we basically, let's do a couple of examples here. Suppose that you have, for example, you want to find the derivative of 6 times x raised to the power 100 minus x raised to the power 55 plus x plus x. So basically you have to take the derivative of each of these terms individually and then add or subtract, because we said that if there is subtraction, we said that d by dx of basically f of x minus g of x was equal to basically d by dx of f of x minus d by dx of g of x. So, and we said that d by dx of f of x plus g of x is equal to d by dx of f of x plus d by dx of g of x. So whenever there is subtraction over here, you simply subtract. Whenever there is addition over here, you simply add. But in the case of multiplication and division, we had the product rule and the quotient rule, which is a little bit more complicated than this, of course. But of course, in the case of a polynomial, we don't have any division or subtraction. That doesn't really happen. So that's basically that. Okay, so then to solve, for example, to solve this problem, what you need to do is calculate these derivatives each individually and then subtract or add as we mentioned before. So for example, if you have 6x raised to the power 100, the derivative of this with respect to x is going to be d by dx of this expression, and that's going to be equal to basically 100 times 6 into x raised to the power basically n minus 1, which is equal to 99. So that's 600 x raised to the power 99. This one over here, you have d by dx of x raised to the power 55 is equal to 55 x raised to the power 54. This one over here is basically d by dx of x, which is equal to basically 1 times, for example, x raised to the power 0, which is equal to 1. So the derivative of x with respect to x is always equal to 1, because that's just a straight line with slope 1, and that is the slope that you can see over here. So then you can write this as you can write this as the d by dx of this expression or this polynomial over here is going to be 600, for example, times x raised to the power 99 minus 55 x raised to the power 54 plus 1. That is basically the derivative of the function. Or suppose that you have, for example, you have a function like, for example, f of x is equal to 1 plus x squared plus x cubed, for example, plus all the way up to x raised to the power 50, and you want to find the derivative of this function at x is equal to 1. Okay, so to find the derivative of this function at x is equal to 1, what you can do is that you can simply find, for example, f prime of 1, for example, f prime of 1, which is basically the limit of, for example, the limit of f of 1 plus h minus f of 1 over h as h tends to 0. You can do it this way. Which is going to be equal to, so let's see what this becomes. Although it's been basically solved in a different way in the book. So this is equal to the limit of now f of 1 plus h is going to be, well, f of 1 plus h is going to be equal to basically 1 plus h plus 1 plus h whole squared plus 1 plus h whole cube plus all the way up to 1 plus h raised to the power 50. Okay, minus f of 1. F of 1 is basically f of 1 is basically 1 plus 1 plus 1 squared plus 1 cubed plus all the way up to 1 raised to the power 50. 1 raised to the power 50. Now if you subtract this from this thing over here, so this is just equal to, all of these are equal to 1 and 1 and 1 and so on and so forth. So these are 50 terms. So this is basically 51. This part over here is 51. So then you can write this as this whole thing. If I calculate f of 1 plus h minus f of 1, would be basically this whole expression minus this minus 51, which is the same thing as, so f of 1 plus h minus f of 1 is going to be equal to basically all of these terms, h plus 1 plus h squared plus 1 plus h cubed all the way up to 1 plus h raised to the power 50. And then you have a 2 over here and a negative 51 over here. Negative 51 plus 2 is equal to negative 49. Negative 49. And so I can write this as basically h plus 1 plus h squared plus 1 plus h cubed plus all the way up to 1 plus h raised to the power 50 minus 49 divided by h, as h tends to 0. Now what we can do here, is basically as h tends to 0, as h tends to 0, then each of these becomes basically this becomes some number divided by 0, which is not what we actually want. But this would be a little bit complicated unnecessarily. We would have to, I don't know, do something in order to somehow cancel out this h here, which is not really convenient. I just wanted to know what would happen if we did that, and now I know. So now let's use the other way of solving this problem. So basically d by dx of f of x is going to be equal to basically the derivative of each of these basically added together. So the derivative of a constant is basically 0. So this is 0. So this is 1. And this is basically 2x plus 3x squared plus, well, 4x cubed and so on and so forth, all the way up to 50x raised to the power 49. Okay. And these are basically 50 terms, right? Now, so this is basically f prime of x. This is f prime of x. Now f prime of 1 is equal to basically 1 plus 2 times 1 plus 3 times 1 squared plus all the way up to 50 times 1 raised to the power 49. So these are 50 terms, and it starts, so the value of this is 1, the value of this is 2, the value of this is 3, the value of the next one is 4, and so on and so forth. Oh, this is 50, I'm sorry. This is 50. I was just thinking of what happens here. So it goes all the way up to 50. So you just have to add 1 through 50 basically. So this is this n times the sum of the first n natural numbers is basically I think it's n times n plus 1 or something. So the first n, actually we can derive that. See, basically if you have these numbers over here, 1, 2, 3, 4, 5 and so on and so forth all the way up to 50, this is an arithmetic progression. This is called an arithmetic progression. Of course, we could just simply grab the formula from there, but it's fun to basically derive the formula. It's an arithmetic progression. If I write it as 1 plus 2 plus 3 plus 4 plus all the way up to 50, then it will be called an arithmetic. It will be called an arithmetic series. So when you have your numbers in this form separated by commas, it's called a progression. And if you have basically your numbers added to the same numbers added together, it becomes an arithmetic series. And so basically we said that this is an arithmetic progression and this is an arithmetic series. Now, of course, as opposed to this idea of arithmetic being arithmetic, and we call it arithmetic because you can see that, for example, 1 plus 1 is equal to 2. 2 plus 1 is equal to 3, 3 plus 1 is equal to 4, 4 plus 1 is equal to 5, and so on and so forth. Meaning that each, basically there is a common difference between each two terms over here. Any term over here, if you add a fixed number to it, you will get to the next term and to the next term and so on and so forth. And that fixed number here happens to be 1 in this case, for example. Now, you could have another sort of progression called a geometric progression. Geometric progression. Now, this geometric progression is basically written like this. So, for example, you have 1 over here. 1 times 2 is equal to 2. 2 times 2 is equal to 4. 4 times 2 is equal to 8. 8 times 2 is equal to 16, and so on and so forth. That means that every term has to be multiplied by some fixed amount. For example, over here, this is 1 times 2. This is basically 2 times 2. This is basically 4 times 2, and so on and so forth. So every term has to be multiplied by some fixed amount to get to the next term, and this fixed amount is called the common ratio. The common ratio. Whereas basically in this case, each term has to be added to some fixed amount to get to the next term, meaning that, for example, you have 2 plus 1. Here you have 3 plus 1. And so on and so forth. And this fixed amount over here is called the is called the common difference. It's called the common difference. Now, so this was basically all about the geometric progression. And of course, if you write basically 1 plus 2 plus 4 plus 8 plus 16, for example, all the way up to, for example, 50, then this is going to be called a geometric series. So arithmetic series, geometric series. Okay. So now we can just simply forget about the geometric part, because we don't need to work with it right now. And about the arithmetic series, what you need to know, if you want to basically find the sum of these numbers pretty easily using a formula, what you can do is that there is a formula which is basically I have forgotten how to derive that formula, but I know that the formula is S of n is equal to I don't know, n divided by 2. Let me look this up. I have forgotten that actually. Arithmetic progression sum. Arithmetic progression sum formula. Seems that n divided by 2 times 2a plus n minus 1 times d. That's the formula. So they have written it as sigma. You can write it as this, with this notation as well, sigma a plus kd. So this is your these are basically, this is the representative of your terms, and k goes from 0 to n minus 1 basically, and this is equal to n divided by 2 times 2a plus n minus 1 times d. Now there is if you were to derive this formula, it would take a long discussion to derive this formula. We don't have the time for that right now. But you can write this as you can also write this as simply S of n is equal to n divided by 2 times 2a plus n minus 1 times d. The same thing. So assuming that you know the number of the terms, and then the a is basically your first term over here, which is 1. N minus 1 is, well, you know already what n is, and then the d is your common difference. This is your d. This is the common difference. Now, of course, there is a way to find the number of these numbers, and that is basically the a of n is equal to a plus n minus 1 times d. Okay, so if you want to find the nth term of an arithmetic progression, this is the formula for that. Meaning that, for example, suppose that I want to find the 5th term in this arithmetic progression. I just write a of 5 is equal to a, which is equal to 1 over here, plus n minus 1, which is 4 times d, and d over here is 1. So 4 times 1. So this is equal to 1 plus 4, which is equal to 5. This number over here. This is the 5th term in this arithmetic progression. So now suppose that I want to find the sum of the first 50 terms of this arithmetic progression. The way that I can do it, of course I need to use this formula. but somehow I need to find the n over here. So I already have my a over here is 1. A over here is 1. D is basically again 1. But n I need to find out in order to find s of n basically. So I can use this formula in order to find out which term basically this term is. This is the last term over here. So if I use this formula over here, a of n is equal to a plus n minus 1 times d, a of n is basically the term that you're looking for. So I'm looking for this term, meaning that I write 50, and then a is 1 plus n minus 1 times d, which is equal to 1 in this case. You just don't have to write it. So that means that 50 is equal to 1 and 1 cancel out, n is equal to 50. That means that this number over here is the 50th term in the oh, sorry. What the hell was that? Okay, so it seems that we have different kinds of insects over here. Okay, so now I know that this number 50 is the 50th term in this arithmetic progression. Of course, it's easy to find out even without calculation that this is the 50th term, because the numbers go from 1 to 50. But sometimes, of course, the numbers are in such a way that you cannot figure them out, so you need to understand this formula in order to find out which term this number is. And so now I know that basically n is equal to 50, a is equal to 1, d is equal to 1 over here, and so I can use this formula s of n. So s of 50, s of basically the sum of the first 50 terms, the sum of the first 50 terms is equal to n. Oh, it's still over there. Well, I thought it was a b, but it seems it's not. Okay. So the sum of the first 50 terms is then going to be equal to n divided by 2, which is basically 50 divided by 2 is 25, times 2a, 2 times 1, which is equal to 2 plus n minus 1, which is 49, times d. d is equal to 1 here, so that's basically that. So this is equal to 25 times 51 times 51, which is equal to, well, I don't know, 51 times 25 is equal to 5, 25, 0, 2, and 10. So you have 5, 7, 2, and 1275. It's 1275. So that means that the sum of all of these numbers is 1275. Now, just to work a little bit with this, for example, suppose you want to find the sum of the first 5 terms of this arithmetic progression. Again, you can use the same formula here. S of 5 is equal to n divided by 2, 5 divided by 2, times 2a, 2 times 1, plus n minus 1, which is 4 times 1, which is equal to 5 divided by 2, times 2 plus 4, which is equal to 5 divided by 2 times 6, which is equal to 3 times 5 is equal to 15. Now 1 plus 2 plus 3 plus 4 plus 5 is equal to 6, 6 plus 4 is equal to 10, 10 plus 5 is equal to 15. The same number that we got over here. So this is a good way to find basically the sum of some numbers if they are in arithmetic progression, and there is, of course, if the numbers are in geometric progression, there are different ways I mean, there are similar ways to this. Of course, the formula would be different to find the sum of those numbers. So now this sum is 1275. So now the sum of all of these numbers is going to be 1275, and that must be the answer over here. 1275 exactly. Okay, so that is that. Okay, so I was practicing some Hindi alphabets over here, which has of course nothing to do with mathematics really. But anyway, so let's go to the next example, which is you want to find the derivative of f of x is equal to x plus 1 over x. You want to find the derivative of f of x is equal to x plus 1 over x. So basically this function is of course defined everywhere except for x is equal to 0. At x is equal to 0 the function is not defined. At x is equal to 0 the function is not defined. Now let's see if that's I mean where that happens to be important. Now you can take basically, since your function is in the form f of x is equal to basically x plus 1 over x, you can take this as you can take this function up here, you can take this as, so let basically x plus 1 be equal to some function, for example u, and x be equal to v, for example, two functions. And of course basically the derivative of this function u is going to be equal to u prime, which is equal to basically 1 plus 0, which is equal to 1. And the derivative of this function v is v prime, which is equal to 1. So now we said that d by dx of, or d by dx of f of x, is equal to d by dx of this function x plus 1 divided by x, which is equal to d by dx of u divided by v, as we substituted here, and that's equal to basically u divided by v. Well, we said that if we had two functions, if we had the d by dx of f of x divided by g of x, that was equal to basically f of x times, so that was basically d by dx of, let me go back over there, I have forgotten that formula. So we said that if we have d by dx of f of x by g of x is d by dx of f of x times g of x minus f of x times d by dx of g of x. Okay, and then in the denominator you will have g of x whole squared. So now if I if I set f of x, if I set that equal to v, to u, and g of x, if I set that to v, then then this becomes basically d by dx of u to v, which is equal to basically u prime times v minus u times v prime over basically v squared, over v squared. Okay, so then you can write this as u divided by v whole prime. So that's u prime times v minus u times v prime divided by v squared. So we are going to use the same thing over here, meaning that if basically your u is x plus 1, your v is equal to x, then you're going to use this formula over here, u prime, which is basically 1 times v, which is basically x times x minus u times v prime. So u is basically x plus 1 and v prime is equal to 1 over over v squared. Now v squared is equal to x squared. So I can erase these over here. So this is equal to x minus x minus 1 over x squared. These two will cancel out. You will get negative 1 by x squared. Negative 1 by x squared. Okay, so we have another example over here. We have another example over here, which is you want to find the limit of f of x. I'm sorry, not the limit, but let f of x be equal to sine x. Let f of x be equal to sine x. Then you want to find the derivative of this function. So d by dx of f of x, or d by dx of f of x, you can write it this way, or you can write it basically, you can also write it d by dx of f of x. You can write it this way as well. That's equal to the limit of basically f of x plus h minus f of x over h as h tends to 0. As h tends to 0. Now f of, in this particular case, f of x plus h is going to be equal to sine x plus h. And f of x, you already know what that is, so you can write this as the limit of sine x plus h minus sine x over h as h tends to 0. As h tends to 0. Okay, so now you need to use a formula over here in trigonometry, sine a minus sine b. Sine a minus sine b. Let me see what that is. I don't really know. I mean, I know, but I have, of course, forgotten. Sine A minus sine B. Okay. So here what I have is sine x minus sine y. Here what I have is sine x minus sine y is equal to 2 times cos x plus y divided by 2 times sine x minus y divided by 2. So then I can write this as the limit of, this is sine, so this becomes basically your x, this becomes your y, and so you can write this as 2 times cos, now x plus y divided by 2 would be x plus h plus x divided by 2, which is equal to 2x plus h divided by 2. So I write 2x plus h divided by 2, and over here then I have to write sine of x minus y divided by 2, which is x plus h minus x divided by 2, which is h divided by 2 divided by h, as h tends to 0. And so the next thing that we can do is this is the limit of cos so I can write this as basically 2 divided by h is 1 over, basically 2 divided by h is 1 over h divided by 2. Okay, so I can write this as the limit of, this 2 comes over here and becomes basically h divided by 2 cos of, okay, so sine of h divided by 2 and times cos of 2x plus h divided by 2, and as h tends to 0. Now you know that the sine of the limit of sine x by x as x tends to 0, this is equal to 1. We have already had this before. So this is basically this part over here. So I can write this as the limit of basically sine h divided by 2 divided by h divided by 2, and times basically cos of 2x plus h divided by 2, okay, as h tends to 0, which I can write as the limit of basically sine h divided by 2 divided by h divided by 2 as h tends to 0 times the limit of cos of 2x plus h over 2 I'm sorry, that's a part of the angle. This is the part of the angle. So that is the cos of 2x plus h divided by 2. So that's the limit of this as h tends to 0. So this part is equal to 1. And of course, as h tends to 0, h divided by 2 also tends to 0, so there is no problem with that. So this becomes equal to 1. Now this part over here, the limit of cos of 2x plus h divided by 2 as h tends to 0 becomes the limit of becomes basically simply cos x, because basically the limit of, you can write this as the limit of when h tends to 0, so this becomes 0, and so you will get cos of 2x divided by 2, which is equal to cos x, and that is equal to cos x over here, which is equal to cos x. So that means that if you have if f of x is equal to sine x, then f prime of x, which is equal to d by dx of sine x, is equal to cos x. That is basically something that you need over and over again, of course. Okay, so that is that. Okay, so now suppose that you want to find the limit of tan x. I'm sorry, not the limit of tan x. Suppose that you have a function f of x is equal to tan x. You want to find the derivative of tan x. So d by dx of f of x, which is the same thing as d by dx of f of x, you can write it this way as well. You can write it as d by dx of tan x, which is the same thing as so you can write this as basically you can write it as the limit of basically f of basically x plus h minus f of a over h as h tends to 0. Now over here basically you can write this as the limit of tan of x plus h minus, this is of course x, I always make this mistake apparently, minus tan x over h when h tends to 0. Now you need to find so this 1 over h, it seems that I can take it out. Of course it's a constant, I can take it out. So it's 1 over h times no, this is the variable, I'm sorry. This is the variable, so I can write this as the limit of 1 over h times the basically tan of x plus h is sine of x plus h over the cos of x plus h, and here I have tan of x, which is equal to the same thing as minus sine x over cos x and I can write this as, I can write it basically this way. So the limit of this whole thing as h tends to 0. Now so I suppose now apparently you can basically, you can write this as basically the limit of basically cos x times And of course you can multiply this h over here, h times cos x times cos of x plus h. And then over here you can write this as cos x times sine x plus h. And then over here you can write this as cos of x plus h times the sine of x. So cos of x plus h times sine x as h tends to 0. So this is the sine of x plus h times cos x minus cos of x plus h times sine x over h times cos x times cos of x plus h. And then over here what you can do is, now sine of x plus h is the same thing as now we have basically what we have over here is basically sine of x plus y is equal to sine x cos y plus cos x sine y. Sine of x plus y is equal to sine x cos y plus cos x sine y. So okay, so let me see what we can do here. So if I write this as the limit of basically cos x times sine x cos y plus cos x sine y cos x sine y, and then you have cos of x plus h. Of course there is no x and y, there is x and h, so instead of y I have to write h. So there is cos x times this whole expression. Now cos of x plus y is equal to, so minus basically sine x times, I suppose I have to write this as, you know that cos of x plus y is equal to cos x cos y minus sine x sine y. So I write this as cos x cos h minus sine x sine h over h times cos x times cos of x plus h, which is the same thing as here. So you have cos x cos h minus sine x sine h It seems that it's a lot of trouble, really. Okay, so we have cos x here, you have sin x here. So let's simplify this. This is as h tends to 0. We want to take the limit of this whole thing. Sin x cos h, sin x cos h. I think we need to just multiply. So the limit of h tends to 0 of this expression. Which is cos x sin x cos h plus cos squared x sin h minus sin x cos h plus sin squared x sin squared x sin h. There is no such thing in here. And then over here you have cos squared x. Over here you have h times cos squared x cos h minus cos x and h times this whole thing, cos squared x cos h minus cos x sin h, and how do we simplify this thing? Okay, so what we can do, we can write this as the limit of so here we have basically cos x sin x cos h, cos x sin x cos h, so these two will be cancelled out, and over here you will have 1 over basically sin h times cos squared x plus sin squared, which is equal to 1. So there you will have only 1 times sin h, as h tends to 0. And then over here you have I think we have made a mistake over here. So here I can take a cos x out, so h times cos x times cos x cos h minus sin x sin h and so cos x minus sin h is equal to cos x plus h. Okay, so now if I write this way, you still have a problem here. Okay, we have no problem actually. So I can write this as sine h over h. I can write this as the limit of h tends to 0 of sine h over h times 1 over cos x times cos of x plus h. So then this, I can write this as the limit of sine h over h as h tends to 0 times the limit of basically 1 over cos x plus h as h tends to 0. This whole thing becomes 1. And the limit of so then if h tends to 0, this simply becomes 1 over cos squared x, which is equal to secant squared x. Okay, so what that means is that if f of x is equal to tan x, then f prime of x, which is the same thing as d by dx of f of x, which is d by dx of tan x, is equal to secant squared x. Secant squared x. So equal to secant squared x. So d by dx of tan x is basically equal then to secant squared x. Okay, so we have one more thing to cover here before we can hit the exercises, and that is basically, let me see. Okay, so the last question on this list is basically you want to find the derivative of f of x is equal to sine squared x, for example. So you can use the Leibniz product rule. You can write your f of x is equal to sine x times sine x, and so then d by dx of f of x would be equal to d by dx of basically sine x times sine x, and then you have to take the derivative of the first function, which is sine x prime times sine x. I write it this way, and then you add that to basically this first function times the derivative of the second function, which is sine x prime. Now you know that basically d by dx of d by dx of sine x is equal to cos x. So this becomes cos x times sine x plus sine x times cos x. So that's the same thing as 2 times sine x cos x. Now 2 times sine x times 2 times sine x times 2 times sine x 2 times sine x cos x is the same thing as sine 2x. It's the same thing as sine 2x. Basically, you know that sine 2x is the same thing as 2 times sine x cos x, and you can also write that as 2 tan x. You can also write that as 2 times tan x over 1 plus tan squared x. 1 plus tan squared x. 2 times sine x cos x is equal to sine 2x. So that means that d by dx of sine squared x is equal to sine 2x. So that these were basically a couple of things related to polynomials and trigonometric functions. So basically we learned how to do different things in polynomials and trigonometric functions. In the next video we will talk a little bit about these. There is about 11 exercises there. We will solve them and then we will get to the rest. Thanks. So I'll see you in the next video.